All right, welcome class to the third lesson in the chapter on trigonometric functions. So today we're hoping that after this lesson you're gonna be able to evaluate trig functions at special angles using the unit circle. So you're gonna be doing this without a calculator. You're gonna get the exact answer as opposed to just the decimal answer. Okay, so we're gonna be using the special angles that we talked about last time, which were 30, 60, 90, 45, and so on. All right, so let's begin. The first thing that I want you guys to be able to do is to use the skill from last class to be able to draw an angle in the standard position and be able to evaluate the trig functions. Okay, so that's just a side note on the lesson so that you can practice with your SOHCAHTOA. Okay, so that's what we're going to do here. So in this example, we're looking at -3, 4. So we're going to be drawing an angle in standard position using those coordinates. Okay, so notice it says that your point is at -3, 4, which is in quadrant 2. So that means you're 1, 2, 3. You're over here. Okay, so you have your vertex, you have your initial side, and you have your terminal side. And then this is your point -3, 4. All right, so now that we have the point and the angle, what we're going to do is, we obviously know that, we're going to have an angle here, right? But we don't know what that angle is because we only know the coordinates, right? But I'm still going to draw the angle arrow there. And what we're going to do is, we're going to call this little angle here theta. Okay? And that theta is known as our reference angle. We'll discuss that hopefully in another, during class, but this is a reference angle, but this is just our little angle here. But notice that you can make a right triangle here out of this. Right? So where the side of this right triangle is the x-coordinate of 3, and we're not going to use -3, we're just going to do the absolute value. We know that has a length of 3, and we know that this has a length of 4. Okay, so well, just so that it's clear, I'll let you know that this is the -3 side, and then this is the 4 side. All right, so length of 3 though, and then a length of 4. And then we can find the hypotenuse here by doing this Pythagorean Theorem, right? So we have 4 squared plus -3 squared equals c squared. And then, so you have 16 plus 9 equals c squared, so 25 equals c squared, so c equals 5. Alright, so now that's how you set it up. So now we can find sine, cosine, and tangent. So we have sine, theta, remember SOHCAHTOA. Sine is opposite over hypotenuse. So we have the opposite side of theta is 4. So 4 over -3. So -4 over 3 basically. So this is the same thing as negative. Ooh, I'm sorry, I did the wrong side there. So it's opposite over hypotenuse. Opposite is 4. Hypotenuse is 5. Alright, that's sine. And then cosine is adjacent over hypotenuse. So adjacent is -3 side. Hypotenuse is the 5 side. And then the last one, tangent, is opposite over adjacent. So 4 is opposite, and -3 is adjacent, and then we can rewrite it as -4/3, like that. All right, and then those are your answers for the trig functions. All right, so you should be able to do this for any type of coordinate that I give you. You just set up a right triangle, and then label the sides, and then find the hypotenuse, and then you can find the trig functions. So like I said, last lesson we looked at the unit circle, and just recall that the unit circle is a circle of radius 1 centered at the origin. You can use the unit circle and your use of special triangles to be able to find various representations of angles. So we're going to show you how to do that in a little bit. First thing to note, though, is that in a unit circle, the cosine of theta represents the x coordinate, or the x value, and the sine theta represents the y value. So when I mean the y value, I mean the y coordinate. So the ordered pair xy is really cosine theta and sine theta, where theta is any angle. Okay, so in this example, in this unit circle, kind of like the one we had in class, you have your various angles here, right? 30, 45, 60. So these are your special angles. And what we want to do is we want to label the coordinates here, right? So we want to label each of these points on the unit circle. So for this first value, you're going to have, remember that the unit circle is a radius of 1, right? So then that's 1, and that's 1, and so on, right? So this is 1 as well, and that's 1. So that means that this coordinate here is 1, 0. This coordinate up here is 0, 1. This coordinate here is -1 and 0. Because remember, we're talking about xy here, right? This is labeling xy. And then here is 0, -1. Here, I'll bring it down. So let me rewrite that. Oops. 0, -1. And okay, so we got those 4 at least. Now we need to find the middle ones, right? So to find this 30-degree angle, what we're gonna do is I'm gonna show you. I'm gonna draw the angle in standard position for that, and notice that you can form a right triangle here, like that. So that's a right angle. And so now you have yourself a little right triangle here, where this angle is 30 degrees, because this is a 30-degree point. And we are trying to find, for this side, we're trying to find x. Okay, so for that triangle, we're trying to find x, and then this is y. So if we draw it here, we have a 30, 60, 90 triangle. And we've already seen these triangles before in the past few classes. So this is our right triangle. We have, we know that the radius of this triangle is 1, so we know that this value here, this is 1, because that's the radius of the circle. But this is x and this is y. So we should be able to find these values, okay? So remember that for a 30, 60, 90 triangle, you have you have the 60-degree side is the a side, 30-degree side is the a squared root of 3, and then the hypotenuse is the 2a side. So in this case, let's write our equation. So we have 1 equals 2a. So that means you need to divide by 2 on both sides. And so a equals 1/2. Alright, we have that y is equal to a. And we have that, so that means y is 1/2. And we have that x is equal to a square root of 3. Which means that we have a, so x is 1/2 times square root of 3, which that's the same thing as square root of 3 over 2. Alright, so now we know where x and y coordinates are, so we can label them. So this is x is square root of 3 over 2, and y is 1/2. Okay, but then notice that this is cosine, right? So if you did cosine on here, cosine of 30 degrees is adjacent. So now we know that this is square root of 3 over 2. And this is 1/2. So if you were to do cosine of 30 here, right, you would get adjacent, which is the square root of 3 over 2, over hypotenuse, which is 1. So that gives you the cosine, square root of 3 over 2. So that means that the x value is the cosine and the y value is the sine. Alright, so now let's go ahead and find the 45-degree angle. Okay, so we only need to do the 30, 60, 90 and 45, 45, 90 once, because so this one would be a 45, 45, 90. So let's do that one. Alright, so we know that the radius here, this is the radius, it's 1. So if you were to draw that triangle here, you get a radius of 1. So if you need to see that, so that's your radius of 1, and then that's your new right triangle for that. And I'll do it in another color. Alright, so that'll be a real radius of 1 in that example. Okay. So in this case, we're trying to find x and y like we were before. So again, recall that the 45, 45, 90 triangle is a, and a square root of 2. Alright, so that means that y is equal to a, x is equal to a, and 1 is equal to a square root of 2. Which means we can go ahead and proceed to solve for a by dividing the square root of 2 on both sides. So we get a equals 1 over square root of 2, which means that's what x is. Alright, so x is 1 over square root of 2, and y is 1 over square root of 2. So for this guy, we have 1 over square root of 2, 1 over square root of 2. Alright. Let me give myself some room for the 0, 1. So I'll label that up here, 0, 1. Alright, and then so for the 60-degree side, we're going to be using, now we can use a shortcut, okay? So the shortcut now is that for the 60-degree side, we have cosine of 60, okay? So if we look at this triangle right here, so we're now focused on, not that triangle, we are now focused on this triangle right here. This triangle. So cosine of 60 is adjacent, which is 1/2, over hypotenuse, which is 1. So that means that this is going to be 1/2 for x. For sine, sine of 60 degrees is opposite, which is this guy, over hypotenuse, which is 1. So we got square root of 3 over 2. Alright, and that takes care of the 60 degree side. Now to find the other sides, right, so to find 120 degrees, you're going to, so for 120 degrees, that's the same thing as a 60 degree side. So this is really simple. Now, once you have these guys, the rest are pretty simple to find, because you know that 120 degree side relates to the 60 degree side. So you know that the coordinates are going to be the same, except the x is going to be negative. So here you're going to have negative 1/2 and square root of 3 over 2. Alright, and then for the 135 degrees, you're going to have the same thing as the 45 degrees, but your x is going to be negative. For the 150 degrees, your x is going to be negative for negative square root of 3 over 2 and 1/2. Alright, now for the 210, the 210 is related to the 150, okay, because they're the same distance, you know, apart from the 180. So the 210 is going to be the same as the coordinates of the 150 or the 30, except, you know, the x is going to be negative, the y is going to be negative. So here both of these are going to be negative. Alright, and then the 225 is going to be the same as the 135, but both coordinates are negative. And then the 240, same as the 120, but both coordinates are negative. Alright. The 330 here, we'll do this one first. The 330 is the same as the coordinates of 30, but the y is negative. Since we are in quadrant, 4, so the y has to be negative. And then the 315, same as 45, but y is negative. And the last one is 30 degrees. I'll just label it here. 300 is the same as the 60 degrees, but the y is negative. Alright, so now we have all the coordinates, so we can use this to find the sine, cosine of any angle. So if I asked you, okay, what's the cosine of 60 degrees, then you're going to go to the 60 degrees on the unit circle, and you're going to look at the x value. The x value is the cosine value, so cosine of 60 is 1/2. Alright, and so on. If you want to find tangent here, you're going to be using this formula to find tangent. Okay, so we're going to show you how to use that formula and the unit circle in the next page. So we're going to be referring to that unit circle for number 2. Alright, so for part A, you want to do sine of 45 degrees. So you want to go to the 45 degrees on the unit circle, and that is over here, so you can see it's 1 over square root of 2 and 1 over square root of 2. Okay, so the coordinates on the unit circle for that guy is, 1 over square root of 2 and 1 over square root of 2, which means that remember you're looking at x and y, so sine is the y, okay, and cosine is the x, so that's cosine. So that means you're looking at sine or y, so you're looking at the y coordinate here. Okay, and that's it. For cosine of 150, you're looking at the 150 on the unit circle, so that's the coordinates, negative square root of 3 over 2 and 1/2. I'll just write it out here so you know what I'm referring to here. And you're looking at the x value, so that means that the cosine is negative square root of 3 over 2. Alright, it's easy once you have the unit circle ready for you. And then you have tangent of 90. So to do tangent of 90, we're going to do sine of 90 degrees using the formula up here over cosine of 90 degrees. Okay, so now we need to do, we need to look at the coordinates for 90 degrees. So that's 0, 1, right? Alright, so that means that the cosine is 0 and the sine is 1. So we have 1 over 0. Alright, we can't do 1 divided by 0. So this is undefined, okay? So in this particular example, tangent is undefined. In fact, as we'll see, in a graphing chapter, that means that we have a vertical asymptote at that angle for tangent of 90 degrees. So that's just something to keep in mind for future reference. Alright, so now we have cosine of 330. So the coordinates for 330 on the unit circle, square root of 3 over 2 and negative 1/2. But we're looking at the cosine value, so it's square root of 3 over 2. Alright, now we're looking at some radians here, cosine of pi over 3. So remember, pi over 3, so we have radians here, right? So that means that radians have to be on the bottom to cancel. There are pi radians in 180 degrees. So now the pi's cancel and the radians cancel. There's a radian here. And 180 divided by 3 is 60 degrees. So really, you're trying to do the cosine of 60 degrees here. Alright? So, cosine of 60 degrees is, so you're looking at the coordinate of 1/2 square root of 3 over 2. And you are looking at the x-coordinate, which is 1/2. Alright? Tangent is sine over cosine, so sine of that angle over cosine of that angle. Let's figure out what that angle is, though. So 5 pi over 6, so you're going to multiply by 180 degrees over pi. Pi's cancel. 180 divided by 6 is 30. 30 times 5 is 150. So you're looking at the tangent of 150. So this is sine of 150 over cosine of 150. Alright, so let's look at the coordinates for 150. So negative square root of 3 over 2 and 1/2. Alright, so sine, so that the sine is the y-coordinate, so 1/2. And cosine of 150 is the x-coordinate. Alright, remember you're dividing two fractions. So when you divide two fractions, you're going to do KFC. Keep this 1/2. Flip the second fraction on the bottom. And then change to multiplication. Alright, so in this case, the negative 2 divided by 2 is negative 1. So this will give me negative 1 over square root of 3. Okay, so that's the answer for part E, tangent. So tangent of 150 degrees is negative 1 over square root of 3. Alright, so now let's convert the 5 pi over 2. So we have multiplied by 180 over pi. Pi's cancel. 180 divided by 2 is 90. 90 times 5 is 450 degrees. So how do we do it for 450 degrees? We don't really have that angle there, do we? Actually we do, but we had to do one full circle before we do anything, okay? So we're going to go back to the unit circle, and we're going to do one full circle, alright? So we have the 360 degree side, so we know we're doing one full circle and a little bit extra. How much extra? 90 degrees extra, okay? So if we have our, our unit circle, we're at 360 degrees because we did one full rotation, and then we're going to go an extra 90 degrees because 90 plus 360 is 450, All right, so that means we're like over here on this line, on this positive y-axis. All right, so we're looking at basically we're looking at the sine of 90 degrees. So the sine of 450 is the same thing as the sine of 90 degrees. So we're going to look at the coordinates for 90 degrees. Coordinates for 90 degrees are 0 and 1. So the coordinates are 0, 1. So we're looking at the y-coordinate, which is 1. So sine of 450 is 1. Alright guys, and that's it. That's using the unit circle to find angles, and we also did a little bit of drawing the angle and drawing the right triangle given a coordinate. Alright, hope this was useful guys, and I'll see you guys in the next time.